So here we have a potential double replacement reaction. We are combining these two aqueous solutions, and if there's a whole lot of silver and sulfate ions, silver sulfate might precipitate. This problem involves the solubility quotient, Q. So this Q reflects the concentrations of ions that are actually present in the solution, and we compare that to the KSP value. If Q is greater, then you get precipitation, because the KSP reflects the concentrations when the solution is saturated, but not supersaturated. With the numbers that are provided here in the question, we will be finding QSP. For the KSP, that's something we probably have to Google or find in the back of the textbook or whatever. And for silver sulfate, that is our value. So our job is to see if Q is greater than that, and if it is, we'll have a precipitate. Now our Q, it's a lot like the reaction quotient. It's in terms of the equation, the expression is the same as the equilibrium constant, or in this case the solubility product constant, but the values we put in for concentration are the ones that are actually existing in the solution at that instant. And it's actually going to take us a minute to figure out what those are, because we can't just use the 0.1 and the 0.2 that are given here, because effectively they are each diluted when they get combined with the other solution. So we're going to have to use the dilution equation. For silver, we start with 5 milliliters and we end up with 155, so it's essentially a 5 into 155 dilution. And the sulfate only effectively gets diluted a little bit. We start with 150, we end up with 155. So let's plug in those numbers to our solubility quotient expression. And we're not going to forget to square the concentration of silver plus. And we get a value for Q that we can compare to KSP, which remember is this value. Q is lower. So what that means is we could dissolve more silver sulfate and still be below the concentrations associated with a saturated solution. So this solution is not saturated and we're not going to see a precipitate.